Our focus for this lesson comes from Grade 7, Expressions and Equations, Standard A. Use properties of operations to generate equivalent expressions. Our topic for this lesson comes from our Simplifying Expressions and Equations, Equivalent Expressions. Our essential question is, what does equal mean, and how is the equal sign interpreted? Please take a moment, pausing the video if you need to copy down the topic and essential question in your header, along with today's date. Set up your question column and your note column, and resume video when you're ready to begin. We're going to start the lesson with this question: what does the following symbol mean? So I'm turn on the symbol right here. Not what is that symbol or what is the name of that symbol, but rather what does it mean? Let's talk a little bit more about that. Common answers when I ask students what that symbol means is to talk about things like, oh, that means to find the answer, or that means to do something. And they'll say something like, that means to add numbers together, or that means to multiply numbers together. Well, that's not what the equal sign means. Oftentimes, students will come up to that false understanding for a variety of reasons. But the equal sign, a more proper interpretation of what it means, is to have the same value as. So whatever's on the left side of the equal sign has the same value as what is on the right-hand side. It may not look exactly the same, it may use different terms, or it may use different symbols, but when we put this symbol, the equal sign, between two expressions, we're saying that the left expression has the same value as the right expression. So let's keep that interpretation of the equal sign in mind as we work to write equivalent expressions. Alright, so for the following questions, we're going to go over 4 of them. You're going to be asked to fill in the blanks below to create equivalent expressions. So our first one is 7 subtract 4 has the same value as blank plus 3. So what would make sense to put in that blank? Well, sometimes what students will do is, if they have that wrong interpretation, if they think, oh, this means the answer, they'll say, well, the answer to 7 minus 4 is 3, so I'm going to put a 3 here, and then 3 plus 3, well, she wants me to simplify it, so 3 plus 3 is 6. So if someone did that, that would be wrong, right? That is not correct. So let's take a look at what would be correct. So what it's saying is 7 minus 4, well, that does have a value of 3, right? So if 7 minus 4 is 3, what is the only thing I can put here to make those two expressions equal? Well, I already have a 3 here. So the only thing I can add to 3 to keep it equal to, or to have the same value as the 3 on the left, is a 0. So the correct value to put in this blank would be 0. So since the left side, 7 minus 4, is equal to 3 or has a value of 3, and 0 plus 3 has a value of 3, one thing you're going to hear us talk about is the balancing method of thinking about this, and we'd say, well, the left side has a value of 3, and the right side has a value of 3, and that is balanced. So that is correct. Let's try the next one. We want to create, it's an equation right now, we want to make the left expression equivalent to the right expression. On the left we have 4 plus 10 plus 5 is equal to what plus 5? So again, what would make this a true statement? What value can we put here so that the left expression has the same value as the right expression? Well, if you've done this work over here, 4 plus 10 is 14, plus 5 would make that 19. The left expression has a value of 19. So what would have to go here? Well, the to make this 19, I would have to put a 14 right here. 14 plus 5 has a value of 19, and 4 plus 10 plus 5 has a value of 19. And so the left expression has the same value as the right expression, which makes the two sides of that equation equal. Let's try the third one. Probably getting a little faster at these. What would be the correct value to put on the right hand side? We have a plus 0 is equal to blank. Well, anything plus 0 is still whatever you started with. So if you said A, I would agree with you. And for our fourth and final example, the expression on the left is x plus x has the same value as blank x. I'm going to take you a little bit longer to think about that. What do you think? Might be helpful to think that if you're adding the same thing repeatedly, that multiplication is the same as repeated addition. So x plus x, we aren't going to do addition, but we could make it multiplication. We can put a 2 right here and say that the value of x plus x is the same, has the same value as 2 times x. Think about that. If we put x plus x here on the left, would that keep it balanced by putting 2x on the right? I think it would. Here are 4 places where we have filled in the blanks to create equivalent expressions, meaning that we've created the same value on the left as the value on the right. And as you look through it, they don't all look the same. It's not like we use the exact same numbers. In some cases, we use some of the same values or some of the same variables, but it doesn't have to look the same to be equivalent. The important thing is that the expression on the left has the same value as the expression on the right. I just want to close out the video today by talking about some vocabulary. So I'm just going to read through these, and again, just like having these problems copied down, I want to make sure that you have the related vocabulary copied down in your notes as well. The first one is term, which is a number, a variable, or a number and a variable separated by an addition or subtraction sign. So like right here, this expression on the left has 2 terms. It has numbers, 2 numbers, that are separated by a subtraction sign. So 7 and 4 make 2 terms. Same with over here. On this problem right here, the 2x, that's just one term. That's a number and a variable together, and they're not separated by an addition or subtraction sign. So 2x is just one term. So we'll do a little more practice with identifying terms. Since we're talking about 2x, let's talk about coefficients. The number written directly in front of a variable, meaning to multiply. So in this example again, 2x is one term, and 2 is the coefficient, because it is the number in front of the variable, and it would mean 2 times the variable x. Expression we've talked a lot about. It's a math sentence that does not contain an equal sign, so we were talking about the expression on the left and the expression on the right. So each of these parts together, those 3 terms make an expression. These 2 terms on the right make an expression. It becomes an equation when we put 2 expressions of the same value noted by an equal sign. So we created equivalent expressions and we wrote them as equations. That's going to conclude our video for today. Please take a moment to make sure that you have the vocabulary copied down, our examples of equivalent expressions, and the discussion of what it means what the equal sign means.